This is a continuation of our July 10th presentation on information technology. The first thing we're going to talk about is the concept of IT internal controls or information technology internal controls. And the way we're going to talk about this is through this depiction here with these opposing arrows. And what we're saying in this case, as internal controls, IT internal controls strengthen as they increase or go up, the information risk coming out of IT decreases. Now, what is the meaning of information risk? An information risk is the risk that the information is processed incorrectly. In other words, there is a risk that we could get incorrect, improper information out of our IT systems. So as our IT internal controls increase, the information risk associated with our IT processing will decrease. Obviously, that's extremely important in a business because in order to have an efficient and effective and a surviving business, you have to have information that is returned to management that is timely and correct. Also, if you're an auditor, when you're auditing the financial records of the company that are produced by IT systems, obviously you're going to want to make sure that there are sufficient IT internal controls that exist within the systems to help ensure that information risk is reduced to a acceptable minimum. Now, we can't say information risk is eliminated because probably no system is perfect. But what we can do is we can put enough internal controls, IT internal controls in place to help ensure that information risk is reduced to an acceptable or a minimal level. Now we're going to, out of IT internal controls, we're going to break the IT internal controls into two major categories. The first category being what we call general controls. Now, as we say in this bubble here, general controls relate to the information technology organization as a whole, the entire organization. Okay, general controls sustain the conditions under which applications can function properly. So that's what the purpose of general controls are, and we're going to spend some time on that over the next several slides and also multiple choice questions. Now, within general controls, there's another category of controls, and these are called application controls. And these are internal controls associated with individual applications. Here I've depicted three separate application systems. System 1 could be payroll, system 2 could be accounts payable, system 3 could be accounts receivable. But there are separate application controls built into each of these applications or systems to ensure only the correct data is input into the system, the information within the system is processed correctly, and the information is updated and output on correctly and on a timely basis. In some cases, these application controls are the same for each system. In other cases, they can be different for each system. General controls apply to all the applications within the IT organization. Let's talk about some of the, in particular, the organizational controls, which are part of general controls in an IT organization. And again, I repeat here at the top, general controls relate to the information technology organization as a whole. General controls sustain the conditions under which applications can function properly. And here we have a number of positions within the IT organization. Now, obviously, some IT organizations have some of these positions combined, although ideally, these positions in terms of segregation of duties should be separate. Let's talk about the first one. It's called database administrators. Database administrators are responsible for developing and maintaining the organization's databases. And they're also responsible for establishing the controls to protect database integrity. In other words, who is allowed access to the database or certain elements within the database. We have a group called network technicians, which basically these are the individuals who maintain bridges, hubs, routers, switches, cabling, and other devices that connect the organization's computers and maintaining connections to other networks. If the company has an online presence, the company will typically have some or several or a number of webmasters that are responsible for maintaining the entity's web page. And this is fairly important because a lot of times this is the public-facing portion of a company. We have computer operators who are responsible for maintaining the entity servers or the entity's mainframe. A mainframe is simply a very, very large computer that takes the place of a number of servers, or if we have servers, they take the place of the mainframe. We have data librarians, and they are typically responsible for the accountability for all the IT documentation. In other words, all the systems documentation and also all the data that is being stored offline. Systems programmers maintain the operating systems for the mainframes, and they also many times are responsible for maintaining and updating the operating systems on servers and even PC type workstations. Systems analysts are the individuals who design the application systems. Applications programmers are the individuals who actually write the program code that executes the instructions, the computer instructions. One of the most important general controls within an organization is what we call backup and continuity. And if we think of data as being an asset, backup helps protect the data asset and is part of what we call a business continuity plan. Now, the definition of backup is duplicating all data in any critical file on some form of periodic basis. And some companies that can be a weekly basis, other companies daily, some companies it can even be hourly depending upon the type of transactions being processed. Another important aspect of backup and continuity is what we call an offsite location. And what that means, at least one version of backup should be stored at a location that is separate from the main processing site, preferable in a climate-controlled environment. In other words, if you have backup, you do not want to have backup that is co-located with your data that could be directly damaged. Another important backup and continuity aspect is called uninterrupted power source or uninterrupted power supply. And systems basically that are critical to the mission of the company should have some form of generator or battery backup to avoid the destruction or the loss of data. And if we have auxiliary generators, what we can do is it can also allow the business to continue in operations in the event there is some form of power disruption. In many cases, I have been to countries, many different countries, where the power supply is not very reliable. And when the power goes down, since even in many foreign countries, much of the activity is driven through IT systems. When those systems go down, the activity within the facility pretty much has to cease. Another area is what we call fault tolerance, and that means redundancy of hardware to ensure there is no what we call single point of failure. In other words, if your business has one single router, which all traffic is being routed through, and that router, the actual physical hardware itself fails, you now have a single point of failure since you don't have an alternative router or an alternative path to process your data. So your data, basically most companies, especially where they are dealing with online type of applications, real-time applications, they need to have a great deal of redundancy to, so if a part of the system fails, another part of the system is going to pick up the additional work. Another concept is what we call hot sites and cold sites. Now, in the event of a loss of the main data processing facility, a hot site is fully operational, and basically that means it's immediately available. We don't have to do anything. We just kind of throw a switch. A cold site, on the other hand, is really a shell facility where the user can quickly install systems to quickly restore processing capabilities. However, that's not near as quick as a hot site. A cold site is you have the shell, and then you have to order in or bring in all the necessary equipment. A hot site, everything is there and ready to go. Again, under general controls and our controls over operations, we need to consider the potential of malware. And malware comes in three major forms. One's called virus, the other is called a worm, and these all can be considered a virus can be a worm, can be a Trojan horse, and so forth. But we'll specifically talk about these because sometimes on the CPA exam they do differentiate between these and ask you questions. So let's talk about overall virus protection. Okay, a virus basically either it attempts to steal data, lock the data, and that's become really big right now, where data is being encrypted on your own computer and being held for ransom. If you don't pay a fee, you will not get the decryption key to the data. Also, viruses can also destroy data. Now, a virus can spread to other software and even hardware because most hardware functions on the basis of software that's built into it. Now, there's a number of preventive controls that are associated with malware virus protection. A company should have a formal security policy directing people not to do certain things, such as if you find a little one of those little key fobs or whatever on the street, don't go sticking it in your computer because that may have been put there to release a virus into somebody's unsuspecting computers. Make sure the company always buys legal copies of software. A lot of cases there will be software that appears to be legal that somebody gives you, but unfortunately that also many times comes with some form of virus because that's what they want you to do. They want you to install that software and therefore the virus. You also want to avoid, whenever possible, shareware. And the shareware is basically where people share programs and information from different central sites. And again, shareware, there's no guarantee that it's not infected with viruses. restricting access to computers. Some companies now have removed or have deactivated the USB ports on computers so people can't plug in USB hard drives that could basically contain infections. Now, also with virus protection, whether it be virus worms or Trojan horses, typically there's an one of the major internal controls is we call detective control, and it's called antivirus software, where the software reviews or looks for virus signatures when the information is being input into the computer. And what will happen is if the antivirus software detects some signature, it will prevent that code from entering in the computer. But again, remember, antivirus software itself is not necessarily perfect. Also, with virus protection, we can have corrective controls. And one of those corrective controls, again, would be backups. If something happens to your data because of a virus, it's always good to make sure that you have adequate backup. So if you have to start from square one again, you have the backup with which to do that with. Also, antivirus software is also a good corrective control because the antivirus software many times will detect that virus code being transferred and can basically stop the transfer. Now, if you wonder what a worm is, it's a form of again, malware, whether you call it a virus or whatever, but it's basically self-replicating. It gets into a system, and then because of its nature, it replicates itself and sends itself off to other parts of the network, and those replicate and so forth. A Trojan horse is a code that is embedded in a legitimate program allowing some form of unauthorized access or operation. As an example, a programmer could put a piece of code into the payroll system that if their payroll ID ever disappears, in other words, they appear to be terminated, that'll cause the system to crash. The code will go out and cause the system to crash, and that's what a Trojan horse will do. It looks like it's code that's embedded within the legitimate program, but it actually is going to it can actually become harmful code if it's activated in some way. Okay, now let's look at two questions regarding harmful code. Question number 8, which of the following attacks use computers of parties infected with Trojan horse programs? So what type of attack do you think that would be? Again, you have your choices. Go ahead and stop the video. Then when you're ready, you can restart the video. Okay, let's take a look at the answer to number 8. Which of the following attacks use computers of parties infected with Trojan horse programs? And this would be a distributed denial of service attack. Many individuals' computers are used, and they're typically unknown to the owner of the computer. And what happens is the Trojan horse will be activated, and it will start sending transactions to overload a target system, and then degrade that target system's performance, or even better, crash the system. And these are called distributed denial of service attacks, and people don't realize those Trojan horses are sitting there and their computer is sending transactions to a target site, and you get enough of those computers together and they're all targeting one site. That can cause the site to either lose performance or be performance degradation, or it'll crash the site. B is a form of attack, and again, this is a learning slide, a man-in-the-middle attack. Man-in-the-middle attack is an attack where a hacker intercepts packets of information, in other words, being transmitted, flowing through a network. C is what we call a brute force attack, and that's the use of password cracking software to try to gain access to a password protected system. And that's why a lot of companies prohibit the use of dictionary passwords and easy to guess passwords, because they are very susceptible to password cracking software. And D, a password cracking attack, gaining access to a password protected system by continually generating a combination of letters, numbers, symbols, or phrases to arrive at the correct password. Number 9, in defining data processing controls, general controls include, again, you're given 4 answers. Go ahead and stop the video, and when you're ready, go ahead then and restart your video. Okay, number 9, in defining data processing controls, general controls include, and the correct answer is C, controls for documenting and approving programs and changes to programs. So again, general controls relate to the information technology organization as a whole. Again, general controls sustain the conditions under which applications can function properly. And application controls, on the other hand, are those controls generally associated with computer programs and processing. And you can see basically answer A is an application control, answer B is an application control, and answer D is also an application control. So answer C is the only general control out of the 4. Another very important area are access controls under general controls. And access controls prevent unauthorized access to specified system files and other processes. So let's talk about some of those right now, some of those type of controls. Okay, the first one is what we call a device authorization table. And that's a table that sits on, again, as a general control in the company's system. And it limits the devices and terminals that can access certain applications and functions. As an example, there's no reason why a terminal outside of the personnel department should be able to access a personnel database, or there should be no reason why a terminal outside of the accounting department should be able to access the general ledger database. Another form of access control is what we call encryption. And that encodes data being transmitted using a specific algorithm with the key that can only be decrypted by a user with the same algorithm and key. Okay, data that is stored online basically in an encrypted form is called encryption at rest. And typically, many companies don't do this, but if data is online, it should be encrypted, because if somebody can break into the system, they may be able to access the data, but if that data is encrypted and the individual doesn't have the key, they can get that encrypted information, but they cannot necessarily, or most likely cannot, decrypt it. Okay, disposal of media is something that's very important. Okay, if we have issues with documents with confidential proprietary information, we need to shred that information. Or if we're dealing with especially magnetic media such as magnetic tape, that magnetic tape also has to be destroyed. Biometric access. Those are automated methods that establish a user's identity by their physical traits. In other words, it identifies the physical trait of a user that's already been authorized to access. And based upon that physical trait, such as an iris scan or a fingerprint or other type of biometric type of measurement that is unique to that individual, that person can gain access to various IT resources. Security group is a specialized group, typically again within IT, that maintains the security policy of the company. It also actively monitors for data breaches or issues with controls. One other thing that you may get questions on in the CPA exam is user IDs and passwords. Now, remember, user IDs and passwords, the concept of these two terms are basically, you need to know what that means. User IDs, okay, user IDs identify the user. In other words, I am Joe Smith. The password portion authenticates the user. So the user ID identifies a user, and then the password provides something only the user knows. And therefore, password protection is very important. And what I've done here is I've listed some of the practices regarding good passwords. These aren't the only ones, but these are some of the mainstream. Passwords should be changed periodically. They should be at least 8 characters long. They should contain a mix of upper and lower case letters or characters. They should include digits and punctuation, grammar type marks, special symbols. Okay, passwords should not be based upon any personal information, because if an individual has information about you, they may be able to guess your password. Is not based upon any dictionary word, because password, again, dictionary, they call it dictionary attacks, and password cracking software will go through those, the dictionary, and look for dictionary passwords. Don't write your password down, and if you do, make sure it's locked away or put it in your wallet or whatever. Make sure it's not accessible. And the other thing is that passwords, once they're used, they shouldn't be reused again, or at least maybe after about 1 year they could be reused, but you don't want to keep reusing the same password. That's like not changing the password at all. Okay, number 10, which of the following is the most serious password security problem? Again, take a look at the answers, stop the video, and when you're ready, restart the video for the answers slide. Okay, the answer to number 10, which of the following is the most serious password security problem? And that would be A. Users are assigned passwords when accounts are created, but they're not required to change their passwords periodically. And again, that's right out of this password table here, that they should be changed periodically. Users select dictionary passwords, which is something you again, you shouldn't do, although it's not, when we talk about what is the most serious, it's probably not the most serious. C, then, users copy their passwords on a piece of notepaper they can keep in their wallets. Again, we say don't copy your password down, but if you're putting it in your wallet, it's probably not a really big deal. And then D, users can access their applications from the internet. This is a normal method of access to IT resources through the internet, and it's normally secure if the password transmissions are encrypted. Okay, number 11, authentication is the process by which, again, look at the selection, stop the video, and when you're ready, restart the video. Okay, the answer to number 11, authentication is a process by which the system verifies the identity of the user. So again, remember, authentication is where the system identifies the user by the credentials presented by the user to the system. Now, some people would pick C, but this isn't correct because the system verifies the identity of the user. The user does not identify themselves to the system. Number 12, a company recently installed software which utilizes the biometric attributes of employees to authenticate user access to the computer system. This technology likely replaced which of the following controls? So again, review your selections, stop the video when you're ready, restart the video and review the slide. Okay, the answer to number 12, a company recently installed software which utilizes the biometric attributes of employees to authenticate user access to the computer system. Which did this most likely replace? Which technology? And the answer in this case would be C, passwords. Such software, biometric software, such software authenticates the user, then grants the user the appropriate access to the system. Since this is an authentication process, this would most likely be replacing a password system. We spent some time talking about general controls. Now let's talk a few minutes about application controls. And the first area we're going to talk about are, I won't call these necessarily all input controls. I should just call these application controls. But basically, an input control, if we look at that as an input control, it provides reasonable assurance data submitted for processing are authorized, accurate, and complete. In other words, the data coming into the system is coming in and it's data that has been authorized, it's accurate, it's complete, and it's not going to cause some process to blow up in the system and cause the system to crash. Now, there's a couple types of input controls, and that includes what we call online controls and batch controls. Online controls are where we input transactions on an online basis. In the case of batch controls, this is where we input transactions but in batches of transactions. Now, in terms of online controls, what happens is that it's important as these individual transactions are being submitted into the system, the information being submitted again is authorized, accurate, and is not going to cause processing problems further down the line. So as an example, with online controls, in some cases, the online system upfront performs certain checks to make sure that the data is accurate. And based upon that, if it's accurate, it'll allow the data to go through. If not, it will not allow, it'll reject the transaction. And I'm sure we have all tried to input some online transactions, whether it be our banking system or other system, and the information is not necessarily valid, and the system will not process that transaction any further. Now, some of the areas of online controls in terms of input, one would be pre-formatting, where the screen provides all the required fields and checks that all required fields are completed before submission. In other words, if you leave something blank, you're going to get some type of error message saying you've got to fill in this field. Another type of online input control is what we call an edit check. It ensures data for the screen is in its proper context and format. Again, if it isn't, it could cause processing problems or the transaction to be rejected somewhere in the system process. Limit checks means data being entered is restricted to appropriate ranges or to a valid value. in the processing, check digits, it's an algorithm that's applied to basically to a serial identifier to a product to produce a check digit that is used during further processing. Again, it's an accuracy check. And the last one is what we call closed loop verification. And what that says is data entered by the user is displayed back to the user to obtain user approval prior to entry. You'll get an online screen that'll say, is this information correct, or ask you to look at it again. And then if you say, if it's correct, you'll say submit. Batch controls are where we have basically batches of records that are basically processed all at the same time. And some of the input controls there are validation. Basically identifiers are matched against master files to validate input data, because if the information doesn't agree with the master file, it's going to cause an error in the system. So if that's going to happen, you want to reject that from the batch immediately. Completeness, any record with missing data is rejected. Again, if we don't have complete data going in on the record, we want to reject that from that batch input. Arithmetic controls, numeric data is computed and compared to ensure data input is correct. Sequence check, basically there's a check to make sure document order is actually in the correct sequence, and make sure that no required documents in the batch are missing. And another area is what we call run-to-run controls. Data against each batch is checked against each stage of processing to ensure accuracy and completeness. As an example, on a very simple run-to-run control says that if I input 50 records into my system, into my process, 50 records should be processed and 50 records should be output in the system. Those are run-to-run controls. If I have more records, something's wrong. If I have less records, something's wrong. It should equal the 50. Okay, output controls are basically, again, typically because of my input errors. These are called exception listings, which is a list of all transactions that were rejected from the batch. The reason they're not typically rejected for online is online are rejected right at the time you're trying to input something. You have to make the correction right at that point in time. Batch, since the transaction's being processed in a batch, again, we could have items rejected out of a batch which have to be corrected later on. Also, audit trails, very, very important. Okay, should the system, whether it's batch or online, should provide a complete trail of all the transactions processed and what happened to those transactions. Question number 13, a customer's order was never filled because an order entry clerk transposed the customer identification number while entering the sales transaction into the system. So for whatever reason, the data entry clerk, the order entry clerk, just made a mistake on the customer number. Okay, which of the following controls would most likely have detected that transposition? And again, you're given your 4 choices. Review your choices, stop the video, and when you're ready for the answer, restart your video. Okay, number 13, a customer's order was never filled because an order entry clerk transposed the customer's identification number while entering the sales transaction into the system. Which of the following controls would most likely have detected the transposition? And the correct answer in this case is C, validity check. Now let's take a look at A first, sequence test. Okay, a sequence test determines whether records are in the proper order. Well, in this case, there's no indication the records were not in proper order, so this would not be the correct answer. Let's take a look at B, completeness test. A completeness check verifies that all the data necessary to process the transaction has been submitted. And again, it looks like all the data necessary to process a transaction has been submitted. The difference is it was some of the data was incorrect. So, but it would pass the completeness test because all data was there. Okay, let's go on to D. D is a limit test, and that verifies that specified values within the transaction are within a range or even a specific value. In this case, there's again, this is for a specific customer identification number. So it wouldn't be a limit test. Then C, validity checks. Validity checks use selected transaction fields within the transaction for validity by comparison with items already known to be correct or authorized. As an example, the customer's identification number on probably the customer's master file. Okay, number 14, which of the following input validation routines is not likely to be appropriate in a real-time operation? And the answer in this case is C, sequence check. A sequence check determines whether records are in the proper order. This type of check would be applicable to a batch processing environment. Okay, the remainder of these checks would validate the input as it is being entered to prevent erroneous data from being entered online. Number 15, a company uses an online sales order processing system. So an online sales order processing system to process sales transactions. Sales orders are subject to edit checks. Which of the following would be a report of edit checks? Again, go ahead and stop the video. When you're ready, restart the video. Number 15, a company uses an online sales order processing system. So we know online sales order processing to process sales transactions. Sales orders are subject to edit checks. Which of the following would be a report of edit checks? And we're given our 4 choices, and the answer in this case is B, report of all rejected sales transactions. We don't look at report of all sales invoices because those are all the invoices that have actually been accepted into the system. So those shouldn't be a problem because they passed all the edit checks. Printout of all user codes and passwords, that doesn't help our basically inputting sales orders. That's really not pertinent. And a list of all voided shipping documents, that's really not pertinent to our sales orders being input. So the correct answer would be B, report of all rejected sales transactions, because that would be a report of all the transactions that were being input online, but the certain transactions were rejected. So we have to examine those, find out why they were rejected, correct them, and re-input them into the system. Okay, number 16, which of the following control activities should be taken to reduce the risk of transactions being transferred incorrectly from an existing accounting system to a newly installed computerized accounting system? So which of these particular activities will reduce the risk of transactions being transferred incorrectly? So again, look at the answers. Stop the video. When you're ready, restart the video for the answer slide. Okay, number 16, which of the following control activities should be taken to reduce the risk of transactions being transferred incorrectly from an existing accounting system to a newly installed computerized accounting system? And if we take a look at the correct answer, that would be D, independently verifying those transactions. A, segregation of duties. Okay, segregation of duties is important to general controls within an IT function, but really do not apply to processing controls within the system. B, ensure adequate authorization of transactions. Authorizing transactions is important, but it doesn't guarantee the transactions will be processed accurately. In other words, in the transfer, and matter of fact, we probably, if they're already in the system, we know they've already been properly authorized. Now we're just concerned about transferring them from one system to another. C, adequate safeguard of assets. And again, physical security over data processing assets, it's important to the protection of the physical and also the data assets, but it doesn't help ensure the accurate transfer. So D, it's really important to verify that the data being transferred into the newly installed computer accounting system is accurate. Number 17, a firm has recently converted its purchasing cycle from a manual process to an online computer system. Which of the following is a probable result associated with the conversion of the new automated system? Again, we're given 4 different choices. Go ahead and stop the video, make your selection, and restart the video when you're ready. Okay, number 17, a firm has recently converted its purchasing cycle from a manual process to an online computer system. So it went from manual to computerized. Which of the following is a probable result associated with the conversion to the new automated system? Okay, first item is, the answer is D. Traditional duties are probably going to be less segregated. Basically, the first item is processing errors are increased. And actually, the truth would be processing errors are decreased as programming in the system will treat the transactions uniformly, so we won't have manual errors. B, the company's risk exposures are reduced. That's a pretty good answer. But the thing is, there's no guarantee the company's risk exposures will be reduced. Depending upon the system, what's going on within that automated system, risk could actually increase or still remain the same. C, processing time is increased. Actually, with the automated systems, processing time will be decreased. So D, the answer is traditional duties are going to be less segregated. In an automated system, duties that were generally segregated in the past are now performed within the system. Okay. Number 18, as a result of technological developments facing businesses and accountants, and again, let's go ahead and take a look at the responses here, and when you're ready, go ahead to the answer slide. Number 18, as a result of technological developments facing businesses and accountants, the answer will be A, system boundaries are becoming less distinct. If we take a look at this, organizational system boundaries are becoming less distinct as electronic interactions between suppliers, customers, partners, internal departments, etc. continue to grow. Okay, let's go on now to question number 19. Number 19, which of the following is a validity check? So again, you have your 4 separate responses. Stop your video. When you are ready to review the answer slide, restart the video. Number 19, which of the following is a validity check? And in this case, the answer would be C. The computer identifies any transaction for which a control field did not match that of an existing record. Again, validity checks use selected transaction fields within the transaction for validity by comparison with items already known to be correct or authorized, such as when a transaction is compared to a master file. Number 20, which of the following internal control procedures would prevent an employee from being paid an inappropriate hourly wage? And this may take a little bit more analysis, but give it a shot. And again, stop the video when you're ready to review the answer. Please restart the video. Number 20, which of the following internal control procedures would prevent an employee from being paid an inappropriate hourly wage? And the answer in this case is D, limiting access to employee master files to authorized employees in the personnel department. If we take a look at A, basically having the supervisor of data entry, having the supervisor of the data entry clerk verify each employee's hours worked are correctly entered into the system. Hours worked have nothing to do with the pay rate, so that really wouldn't be something that would be applicable. B, using real-time posting of payroll so there can be no after-the-fact data manipulation of the payroll register. Again, real-time posting would not prevent improper wage rates from being set. C, then giving payroll data entry clerks the ability to change any suspicious hourly pay rates to the appropriate rate. Okay, only personnel department employees, when we think about segregation of duties in payroll, only personnel department employees should be allowed to change labor rates. Payroll is only responsible for entering the hours worked. So the answer in this case is D, limiting access to the employee master file to authorized employees in the personnel department would be the correct answer. Okay, number 21, which of the following represents a lack of internal control in a computer-based system? And you're given 4 choices. Go ahead and stop the video, and when you're ready with the what you believe to be the solution, restart your video. Okay, number 21, which of the following represents a lack of internal control in a computer-based system? And the answer in this case is D, programmers have access to change programs and data files when an error is detected. And as part of the general control environment over IT, a functional separation of computer activities is necessary for the proper internal control. Once programs have been placed into production, the production environment, programmers should have no access to these programs unless specifically authorized by management. Question number 22, the risks associated by rapid changes in the IT environment have not affected which concepts of internal control? And again, you're given the internal control concepts and have to identify the items that have not been affected even with the rapid changes. So go ahead, and when you're stop the video when you're ready, go ahead and restart the video. Number 22, the risks associated by rapid changes in the IT environment have not affected which concepts of internal control? In this case, the correct answer is D, all concepts, 1, 2, 3, and 4, including cost-benefit analysis, the control environment, reasonable assurance, and management's responsibility. Okay, we're going to talk about this last area, which is called the system development life cycle. And the reason I'm going to spend a little time on this is that this is an area that they do test. If you're going to see IT type of questions, this is a favorite area of the examiners. The system development lifecycle is basically in effect, a standard methodology for designing an IT system, and there's basically 5 major components to it. And what the examiners like to do is they like to say, okay, here's an activity. What component does that activity belong to? What SDLC category does that activity belong to? So we're going to go through these 5 categories, these 5 SDLC categories, and talk about kind of what happens in each one at a 10,000 foot level. The first one is definition of the system. It's basically the user needs have to be defined. What do the users need from the system? Also, as part of that process, the technology that is going to be employed. Are we going to use basically what type of technology is going to be employed. Also, what are the personnel and the money resources and the hardware and so forth? What are the resource commitments that are going to be involved? And we're also going to be performing a cost-benefit analysis. What is the cost of this system versus what are the benefits? This is typically involves a review by what we call an IT steering committee, because there are a number of organizations within a company that are competing for limited IT resources. So there needs to typically be an IT steering committee that helps allocate the resources out to the based upon the proper cost benefit uh, based upon a proper cost benefit analysis. So typically during the definition phase, the IT steering committee is involved, and once the IT steering committee approves the project, it gets put into whatever sequence it gets put into based upon approval, and then that project will be put into the design phase, where the systems analyst primarily will start developing a different type of analysis to how the system's going to be working. And here I say identifying data elements and conceptual processing flows through the data flow, basically through data flow diagrams and through flowcharts, interactions with new or existing systems. Much of the work is performed by systems analysts. So the type of data elements are going to be basically going to be identified. The data paper and the processing flow of the system is going to be established, and also the physical design. At the same time, when we're creating the data elements, where the systems analysts are also looking at other systems and saying, wait a minute now, do we have to have that data element in this new system, or can we pull that data element from an existing system? In other words, we want to eliminate the possibility of having a lot of data redundancy. It all, the data, that unique data should be in one source. Once it goes past the design phase, we get into the development phase, where basically the programmers take over, and the program, and we go into program and database coding, and testing using what we call non-production test beds. In other words, we don't use live data to, in effect, play with. We want to utilize data that is realistic. Maybe it'd be a copy of data from our normal systems and so forth. But we also want to create data that will also challenge the system. What happens when it hits certain anomalies of data and so forth, to see how the programs react and so forth. So IT must demonstrate the system performs within the desired functionality parameters. And at that point also then is when the system's ready to go, there has to be a formal user acceptance of the system. And again, as I said, much of the work during the development phase is performed by the programmers. And again, users are going to be the approval or user acceptance. Basically, users are going to have to approve the system before it goes into production. Once the system is basically approved to go into production, we have to come up with an implementation plan. In other words, how to bring that test system now, convert it into a production system. And so we have to go plans and converting to production. And the process of placing the system into production, basically status is for the implementation. And typically it involves one or a combination of the following conversion methods I have listed. As an example, many times what will happen is a company will create a parallel processing environment, which means that they will keep the old production system up and running, and they will also start running the new production system. In other words, they're processing in parallel, and these systems, all the information in the system should agree. And the advantage to that is obvious that if something is wrong with this new production system, they could still fall back on the old system. Cutover is basically what I call the the all or nothing, where you turn the old system off and turn the new system on, so it's sink or swim. That's a fairly how do I say, that's a fairly aggressive way to do it. And some companies do that. Some companies it works out. Other companies, people have to find new jobs as everybody's fired because the cutover didn't work. Another type is a pilot system, where we create a small version of the system and test it out as we're running it in effect in parallel to the old production system. Or we can bring the system in phases, where we break the implementation up into certain phases, and as those phases come online, they're compared to the system we're running in parallel. If those work, we eliminate that portion of the old production system and rely upon that new production, and keep doing that in phases until we've activated the entire new production system. Also, during the implementation time, with the user community, there should be training, and the documentation of the system should be taking place. And also, probably a year, it's part of implementation, and happens about a year after the system's been fully running, and that's where the user community or the IT steering committee will do a subsequent review of the system to make sure the system has fulfilled the necessary requirements that were defined initially in the definition of the system, and where did the system achieve its cost benefit function, and so forth. After that, then, after the system is fully implemented, in other words, it's fully in production, we now then enter what we call the maintenance phase. And the maintenance phase is basically where the system now is the official system, production system of the company. At that point in time, it's controlled, and any type of changes that are done to that production system are through a controlled maintenance procedure, where now that system's in production, the only changes that are made are based upon user requests that have been approved through management and so forth. So that's a real 10,000 foot view of the system development lifecycle. Let's go on to the final question, and I've tried to build it as a simulation. Okay, 23 again is a simulation, and it says for each of the following, in effect, activities, for each of the following, identify the most likely SDLC phase each activity would most likely occur. So you have the activities here on the left, A through G. Over on the right-hand side, you have the different categories of the system development lifecycle to select from. Notice with the SDLC, I did not include the SDLC in the order of the SDLC. These are in somewhat random order, so you have to basically pick and choose the correct item. And this is something would the most likely also be a tactic with the examiners. So go ahead and try the question number 23, the simulation. Try to match that up with the correct item. And also notice that there may be situations where there is no one or two of these categories, the SDLC categories, may not be used, or they may be used several times. So go ahead and go through the simulation, stop the video, and when you're ready, restart the video and come take a look at the answer slide. Okay, number 23, the answers. If we take a look, 23A, the process of monitoring, evaluating, and modifying a production system. So the system's already in production. Therefore, at this point in time, the system would be in the maintenance phase. In other words, we're monitoring, evaluating, and modifying a production system. That would be the maintenance phase. So that would be the answer in this case, would be C. In the next one would be B, a cost-benefit analysis is performed. And if you'll remember, that is typically performed up in the definition phase, which would be D. And again, that's going to be evaluated by an IT steering committee. Okay, the phase where systems analysts perform the majority of their functions, and the systems analysts are typically most involved during the design phase. So the answer in this case would be B. The phase where the IT steering committee is most involved, we just talked about that a few minutes ago, and that would be during the definition phase, which would be D. E, the phase where parallel processing would most likely be performed, and we talked about there are a number of different ways of conversion, which is part of our implementation process, which would be A, implementation. The phrase where user training occurs also would be A, during the implementation phase. And G, identifying areas where data elements may exist in other systems to avoid data redundancy. And that would be under the design phase, which would be B. And with that, that will be the last question for information technology. So that's the end of our classroom presentation. Thank you so much for your time.